I've heard people say this throughout my life, and I've just taken it for granted, but sometimes it's good to ask the question, is that really true? So today we're going to try to answer this question together. We're going to see how plausible it is that people actually breathe the same air, which means that the same particles that I breathe in and breathe out goes into somebody else's mouth for them to breathe in and breathe out. Is that really true? Because this might not be true, because the world is so big, there's so much air. What are the odds that we end up breathing the same particles in? It seems reasonable that if you're within the vicinity of another person, if you're close to another person, then chances are, yeah, if you're in the same room, you'll breathe the same air. That's how people get each other sick, right? So obviously some people are going to exchange breathing particles, but that's not really the question. The question is it possible for every single person to share breathing particles with everybody else on Earth? That's the question. So let's dive into it. Let's answer this question. Okay, this question says, what is the ratio of the number of particles in one breath of air relative to the available breaths of air on Earth? Use the following values for the average pressure, volume, and temperature of Earth's atmosphere. Average pressure is 101.32 thousand pascals. Average volume is 6.13 times 10 to the 18 cubic meters, and the average temperature is 288 Kelvin. Assume an average tidal volume of 500 milliliters. Tidal volume, that's the amount of air that we breathe in on average. The amount of air that you breathe in is called the tidal volume. And on average, our tidal volume is half a liter. So we're going to be using these numbers to take the ratio of the number of particles we breathe in one breath versus the total amount of breaths of air available on Earth. The air around us is non-reactive. In fact, we hardly notice it unless the wind blows, or if there's a hurricane, or if there's a fire. For the most part, we don't even recognize that there's air all around us. So that tells us that we can model the Earth's atmosphere as an ideal gas. And when it comes to an ideal gas, what equation comes to mind? You should know the equation of an ideal gas, because we all learned this in middle school, and it's PV equals nRT. P is for the pressure, V is for the volume, N is the number of moles, and mole stands for a certain number of particles, which is a very large number. And R is the ideal gas constant, and T is the temperature in Kelvin. So this is the equation that we're going to use to answer this question. We can use the ideal gas equation to get the concentration of particles in the atmosphere. So that will be the number of moles divided by the volume of the atmosphere. So that would be N over V. So solving for N over V, we get RT divided by P. And when we plug in the values for P, R, and T, we get 42.31 moles per cubic meters. So that is the concentration of particles in the atmosphere, approximately. And now that we know the concentration of particles in the atmosphere, we can now find out how many particles are contained within one breath of air. Now, one breath of air is approximately 500 milliliters. And now we have to convert milliliters to cubic meters. And we know that 1 milliliter is 10 to the minus 6 cubic meters. So we multiply 42.31 times 500 times 10 to the minus 6, and we get 0.021 moles. So when you take in one breath, on average, you take in 0.021 moles of particles. And now we want to know how many particles are contained within 0.021 moles. For this, you have to remember Avogadro's number. Avogadro's number gives us the definition of a mole. Remember, a mole is a certain number of particles given by Avogadro's number, which is 6.022 times 10 to the 23 particles. So we multiply 0.021 times 6.022 times 10 to the 23, and when we multiply these numbers together, we get 1.26 times 10 to the 22 particles. Wow. So whenever you take in a breath, you inhale this many particles. Now let's find out how many breaths of air are available on Earth. We know that the volume of air on Earth is 6.13 times 10 to the 18 cubic meters, and we divide this volume by the volume of one breath of air, which is 500 times 10 to the minus 6 cubic meters. And when we divide these two numbers, we get 1.23 times 10 to the 22. So when we take the ratio of the number of particles to the number of breaths of air, we get a number that is greater than 1, which means that every time you inhale and exhale a breath, the number of particles that you inhale and exhale is enough to be shared with everybody on Earth. So not only are you inhaling and exhaling the same particle as people in your vicinity, but you're actually inhaling and exhaling particles with everybody else on Earth. And this right here is a good mathematical way to convince yourself that that is true. So you guys can't tell me that math and science is not amazing. The fact that we can answer questions like these and show how much we actually have in common is amazing to me, and it's a big part of why I fell in love with math and science. It gives us an ironclad understanding of the world and allows us to see things for what they really are. All right, so I definitely wanted to share this calculation with you guys. And when we look at the answer choices, the correct answer is going to be answer choice C. There are more particles in one breath of air than there are breaths of air available on Earth. And I hope that this was an eye-opening video for you guys. If you want me to make more videos like these, go ahead and give the video a like. Go ahead and interact with me in the comment section so that I can get to know some of you guys, and continue to look out for videos like these every week. We're growing slowly but surely, but the most important thing is that we have fun doing it. And I definitely had fun shooting this video and doing this calculation, and I hope you guys did too. So I'm going to leave you with that, and as always, I'll see you guys in the next one. All right, bye-bye.